risk robotic explorers. And when it comes to Mars, it's probably just as well.
Getting to Mars is just unbelievably hard. We've learned that the hard way. Before, certainly if you go back to the days before the rovers launched, 2/3 of the missions that have been flown to Mars had failed. And they failed for all kinds of reasons. Rockets that blew up and spacecraft that just vanished hardly without a trace.
In fact, landing on Mars has always been hit or miss. But so has blasting off from Earth at exactly the right time.
The right time to go to Mars, basically the only time to go to Mars, is when Earth and Mars are properly aligned with one another. You have to wait for them to get into just the right position to go from point A to point B. And you've got to be on the launch pad ready to go when that launch window is open. And if you miss your opportunity, you don't get to try again for 26 months.
5, 4, 3, 2, 1, engine start. Liftoff of the planet Mars.
If you are ever lucky enough to book a flight on the first rocket to the Red Planet, you'd better be sure you've packed everything. The one-way trip is at least 6 months, with no turning back if you've forgotten something.
We can go to the moon and get back in a week. It takes about 3 years to go to Mars and come back. You have to carry your food, you have to recycle your breathing oxygen and your water. So it's a very, very major undertaking. Within about 3 days, the Earth looks very small, and within a week, it's just another star. And you suddenly are going to realize you're in very deep space, and it's going to be a long time before you can go back.
Before we take this giant leap, we need to be able to carry everything needed for a 3-year round trip with us. This is a much larger effort than getting to the moon. It's the Apollo mission on steroids.
At this point, we know at least as much as the engineers knew at the time that they agreed to land on the moon. And they had only 9 years, so I think once the nation decides they really want to land humans on Mars, the system can be designed and developed and built.
Fast forward to the future. After 6 months crossing the blackness of space, things suddenly get a lot more interesting. The combination of a high approach speed, a thin atmosphere, and twice the gravity of the moon makes Mars one of the hardest places to land in the solar system, even for robots.
You hit the top of the Martian atmosphere, you go on Mach 27 times the speed of sound. And for our vehicles, between when we hit the top of the Martian atmosphere and when we were bouncing on the surface with the airbags was 6 minutes. It's a hell of a ride. You use a heat shield to slow you down to a leisurely Mach 2, twice the speed of sound, and then we throw out a supersonic parachute.
Everything is complex, and everything has to happen precisely on time.
The worst part is when you come into contact with the Martian surface. There's no runway, okay? There's no nice place to land. And you can't control very well where you're going to come down. So you're going to come down in a field of rocks like this. How do you guarantee that your $1 billion spacecraft is actually going to survive that? The approach that worked for us with our rovers was great big airbags. Bounce, 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 bounce. Finally, the vehicle comes to rest. Vikings used rocket motors, and they just touched down gently on the surface, and they were fortunate. It was just good luck. They landed in a field of boulders like this, but they didn't land with one that was poking through the belly, and it all worked. You have to be good, and you have to be lucky.
A safe arrival is your passport to a dangerous new world. This is a planet where the atmosphere is your enemy, and even the dust is dangerous. Want to step outside to take in the scenery or pick up some rocks? As familiar as it might look beyond the porthole, Mars is dangerously alien. The upside is that the low gravity will give you super jumping abilities. The down, the almost complete lack of an atmosphere. This is not home. There is nothing here to breathe. To find similar conditions of low temperature and pressure on Earth, you have to travel 3 times higher than a commercial airplane, to the very edge of space. Planetary scientist Bob Brown shows why you should keep your helmet on when visiting Mars.
We have this, just a beaker full of water. We're going to put it in this little chamber. And attach a vacuum hose to the chamber and pull the air out of the chamber.
As the pressure drops to Martian levels, the water boils at room temperature.
So if you were to take your helmet off on Mars, the liquid in your face especially would start to boil, and much the same as this liquid water started to boil, and I guess I don't have to describe what that might feel like or what it might look like.
A medical travel advisory might say to keep your suit tightly fitted, but so far, no one's built a suit that'll work on Mars. Existing spacesuits are simply too bulky, too heavy, and too complicated to wear for the sort of regular activity required on the unforgiving surface of Mars. Like Steve Squires, planetary scientist Chris McKay roams the remote Mars-like regions of Earth. Here, in Australia's arid Flinders Ranges, he hunts for the extreme ways of living that we might find on Mars. Organisms like the bacteria that makes the green smudge inside these white desert stones.
If I was trying to do on Mars what I'm doing here, the biggest problem would be a suit that I could use to go outside. Something we take for granted here. I get up in the morning, I put on a shirt and a pair of jeans, and out I go. So it's got to be routine, easy to use. Many times I've been working out in the field in the Antarctic or the Arctic, and I just have to take the gloves off because I'm doing something that requires that quintessential human capability of touch and feel and hold. So my request to the engineers is give me a spacesuit with gloves that'll keep me warm and keep me pressurized, but still allow me to use my hands.
Not only will you want to move your fingers, you'll want to move around. NASA's Lunar Electric Rover is a prototype for future missions to the Moon and Mars. It's part vehicle and part spacesuit.
I can just picture being there in a vehicle of this type and looking back at Earth in the distance and deciding to go EVA and being boots on the surface in 10 minutes, which would just be a remarkable breakthrough.
Astronauts can cover more ground by living in the vehicle for weeks at a time, stepping outside when they want to, and back inside at the first sign of danger.
Mars does not have a powerful magnetic field the way Earth does. So there's radiation from the sun, also cosmic rays that are going to penetrate through spacesuits.
An astronaut might get a 30-minute warning of an incoming solar storm, but less predictable is the risk of being hit by a meteorite. Recent estimates based on fresh crater counts suggest that up to 200 new holes are blasted into the surface of Mars each year. And even the Martian moons are not guaranteed to stay in place. The days of Phobos are numbered. Possibly an asteroid that once strayed too close The moon is trapped in a fatal gravitational embrace. Every passing century sees it drop 6 feet closer to death. In about 50 million years, its fall is expected to be complete. The aftermath, if anyone is around to see it, could be Mars with a bright ring of moon dust to rival Saturn's. But events like this are not your real danger. It's the day-to-day exposure to the cold, dry Martian environment that will make a long stay tricky.
It was 119 degrees Fahrenheit here yesterday. Really, really, really hot day on Mars. It'll get up to about 30 degrees Fahrenheit, and at night it goes to more than 100 below.
Martian deserts are both frozen and sun-baked. With no ozone layer, UV levels are so high that any unprotected organism, even a Martian microbe, will be burnt to a crisp within minutes. A good hat is just not going to cut it. So why not leave all the dirty work of exploring Mars to robots?
One thing about humans is that they have a capability to improvise on the spot, even if you don't have the right tools with you, that robots lack. In Death Valley, this stuff was wet, it got dry. When it dried, it cracked. We're investigating the idea that something similar happened on Mars. You know, I'd love to be able to do this on Mars, and we can't. You know, human on the scene can improvise pretty well.
Getting down and dirty on Mars will mean exactly that. Moon dust caused enough problems for the Apollo astronauts, without an atmosphere to blow it around. On Mars, dust is going to be a serious problem.
Mars is a dusty place. In fact, it's a lot worse than this. When you think Martian dust, you shouldn't think sand. It's more like cigarette smoke. Very, very fine-grained stuff, and it gets everywhere. Coats everything. People are going to breathe it in. It's going to get into the habitats. It's going to get on people's spacesuits and their clothing. It's going to be a real challenge, and I think they're going to have to devote a lot of effort to finding ways to deal with that dust, because it's horrible stuff.
When an ill wind blows on the red planet, dust really does go everywhere. About once every 3 years, local storms go global, and the dust can block your view for months. It happened the very first time we sent a probe into orbit in 1971.
When Mariner 9 got to the planet, there was a giant dust storm that had completely shrouded the surface from it.
They could see nothing, just dust. And as the dust started to recede, all of a sudden these dots appeared. There's 3 of them lined up. What the heck are those? Turned out to be the peaks of the 3 great volcanoes on Mars.
And that's when we began to realize just how varied the terrain and topography of Mars was.
This was the moment that Mars began to reveal itself. A world with a secret history and the spectacular scenery to match. Tired of the Earth's scenic sights? The Himalayas not high enough? The Grand Canyon too small? Try the Red Planet for sightseeing on an enormous scale. Thanks to our sharp-eyed spacecraft, Mars is opening up like never before. These are real landscapes that humans will one day marvel at in person.
You know, if you're going to Mars, you'd want to go for the scenery, right? I mean, you're not going for the culture. You're not going for the climate. So you definitely want to go for the scenery. One thing that people forget is that when we've landed on Mars, we have to go to places that are safe, and safe equals pretty smooth and flat. There are places where the scenery on Mars is just breathtaking.
Here's a bit of Mars that's anything but smooth and flat. The magnificent Valles Marineris, this titanic canyon system. over 2,500 miles long and 6 miles deep, is probably the grandest geological feature in the solar system. It's clearly the Red Planet's must-see destination.
As a human being, it's the sheer gigantism of Mars that is amazing. The Valles Marineris beats the Grand Canyon hollow, and if you've ever seen the Grand Canyon, you will never forget it.
It's so colossal, the Grand Canyon would be easily swallowed by one of the smaller side branches.
We're talking about something here that's the width of the United States or of Australia across here.
So I think the Valles Marineris would be the place to go. I mean, build a lodge right on the rim so you can look in.
The attraction goes beyond sheer scenic splendor. Deeper than the canyon itself is the mystery surrounding its formation.